Welcome to this Maths Made Easy video on integration by substitution. To start with, let's take a look at how to integrate by substitution. So the first thing we need to be aware of here, step 1, is you need to be actually aware of what an integration by substitution question looks like. And in this case, you will be presented with an integrand that is made up of two functions of x. Okay, so we just need to be aware of what we're looking for. Now for step 2 here, we substitute u equals f of x, where f of x is one of the functions of x. Step 3 then, we find du by dx. So this was step 2. For step 3 here, we find du by dx. Okay, so we find du by dx. And then we rearrange to get dx in terms of du. So we rearrange here. We rearrange to get dx in terms of du. Okay. Step 4 then, we rewrite the original integral in terms of u and du and simplify if we can. So step 4 here, we just note that we rewrite the original integral. Okay, so we rewrite the original integral. Step 5 then. If we choose our substitution well, you will now be left with something much easier to integrate. And to note here, sometimes you will be given the substitution in the question. So now we have something much easier to integrate. Assuming we've obviously chosen a good substitution. So much easier to integrate here. Of course, if this isn't much easier to integrate, then you might need to reevaluate your substitution. Step 6 here, we then need to integrate. So we integrate here. And finally for step 7 then, we substitute u for f of x in the answer to get the final answer in terms of x. So substitute. So we substitute u for f of x in the answer to get our solution, to get the answer or the solution in terms of x. Okay, so that gives us everything we need there for how to integrate by substitution. Let's take a look now at changing the limits. So for a definite integral of the form a, b, with our limits a and b here, if our substitution is u equals f of x, so u equals f of x, then rather than substitute x back in at the end, we can just simply change the limits to become f of b and f of a. Okay, and we then simply put those limits into our expression for u to evaluate the integral. So if we take a look at this example here, and let's just clear this so we've got enough room. Well, in this case here now, we're looking to find the integral of 5x to the 4 e to the x to the 5 with respect to x with these following limits. And we know u is equal to x to the 5. So here, u is equal to f of x, so u is equal to f of x, which is equal to x to the 5. So in this case, our limits would become 0.5 to the power of 5. And that's equal to 0.03125 there. And of course, if we substitute the lower limit in here, that's 0 to the power of 5. And of course, that would just simply give us 0. So now if we find du by dx, so du by dx, what would that give us here? Well, differentiating this here with respect to x, well, that simply gives us 5x to the power of 4. And now if we rearrange this, what we find is du is equal to 5x to the 4 times dx. And in that case, we can write dx as du divided by 5x to the 4 there. Okay. So here now, our integral becomes, so therefore the new integral is simply going to be, well, first let's consider the limits here. As we've noted, our limits will be 0, my lower limit, my upper limit is 0.03125. And the integrand now is going to be 5x to the 4 times e to the u, du over 5x to the 4. Okay. Well, in this case now, the 5x to the 4 here will cancel with this 5x to the 4, and all we simply get left with then is the integral of e to the u with respect to u. Okay, and don't forget our limits here of 0 and 0.03125 there. So here, if we integrate this with respect to u, that would just simply give us e to the u. So all we need to do now is evaluate e to the u with our limits here. So that's 0, 0.03125. So here now, what we want to do is just evaluate this. So in that case, what we get then is e to the 0.03125. And remember, for the lower limit here, we just substitute our lower limit in and we subtract this off. Okay. So if we do that, what we'd get here is minus e to the 0. So it gives us minus e to the 0. And if we evaluate this on our calculator, what we get here is 0.0317 there. Okay. So that gives us our solution there to that example, and that gives us everything we need for changing the limits. Moving on now to take a look at integration by substitution on fractions. Now when you're choosing a substitution for a fraction, the best thing to choose is almost always the denominator, or a part of the denominator. So here, we take a look at this example, we're asked to integrate 4x cubed over x to the 4 minus 1, all to the power of 1 over 6. Okay. And here we're integrating this with respect to x. So here we need to choose the substitution. And here it makes sense to choose our substitution to be this bracket, this x to the 4 minus 1. So therefore, we let u equal x to the 4 minus 1. And remember, the first thing we do here is we differentiate this with respect to x. So du by dx is simply going to be 4x cubed. Obviously, as minus 1 is a constant. If we differentiate that, that just gives us 0. So du by dx is 4x cubed. So therefore, we can evaluate du here, rearrange him. So it gives us 4x cubed dx. And we can also find dx here by dividing by 4x cubed. So therefore, dx is equal to du over 4x cubed. Okay, so we've got everything we need now. All we simply need to do is rewrite our integral. So here the integral of 4x cubed over x to the 4 minus 1 to the power of a 6, or 1 over 6, sorry, with respect to x. Well, rewriting this now, this becomes 4x cubed over u to the 1 over 6. And then here, don't forget our dx is du over 4x cubed. So that's du over 4x cubed. Okay. Now notice straight away, this 4x cubed here will cancel with that 4x cubed. So what I get left with now is the integral of u, or 1 over u to the 1 over 6, which we can write as u minus 1 over 6 there. And don't forget du here. Okay, that's been left over. So here now, we just simply need to evaluate this integral. So in that case, add 1 to the power and divide by the new power. So what we get here is 6u to the 5 over 6, and we divide that by 5. Okay. Don't forget, as we have no limits here, we need our constant of integration. And all we need to do now is substitute our u back in here. So we know u is equal to x to the 4 minus 1. And if we substitute that back in, then what we obtain here is 6 over 5 x to the 4 minus 1 all to the power of 5 over 6. And again, don't forget our plus c there. So that gives us everything we need there for integration by substitution on fractions. And finally, let's take a look now at trigonometric integration by substitution. So integration by substitution questions involving trigonometry can be very difficult. They involve not only skills such as integration, but also a good knowledge of trigonometric integration and trigonometric identities. So if we take a look at this example here, we're asked to integrate sec x over tan x to the power of 8 using the given substitution here. So as we've been given u, first let's find du by dx. So here, du by dx, well that would simply be here sec squared x. Okay, so that's sec squared x. And once we've found du by dx, we want to find du and then dx. So du here is simply sec squared x dx. And then finally dx is given by dividing through by sec squared x. So dx is equal to du over sec squared x. Okay, so that gives us everything we need there to start this question. So what we want to do now is start rewriting our integral. First, what I'm going to do here is deal with this power of 8. So we can write our integral here as sec to the power of 8 x over tan to the power of 8 x. We're integrating here with respect to x. So here, what I'm going to start doing now is rewriting this. So we know dx is du over sec squared x. So if we start putting all this together then, what we've got here, and remember we've got tan 8 power of x here, so put everything together here, what we've got now is sec 8x, so don't forget our integral sign here, over u to the 8, okay, because u is equal to tan x, so tan power of 8 here, that would be u to the power of 8, and dx then is du over sec squared x, so du over sec squared x. Okay, so we notice straight away I've got sec squared x here, I've got sec to the power of 8 here. So what that's going to do then is give us sec to the power of 6 here. So rewriting this becomes sec power of 6x. So sec to the power of 6x all over u to the 8. And then this changes to du here. Okay, this gets left over this du. So the question is now, how do we deal with this sec to the power of 6? This is quite difficult. So here now we need to start using our trig identities. So if we do this in a different colour just so we can see that this is just for the sec to the power of 6 here. Well, if we start at the top here, recall that sec squared x is equal to tan squared x plus 1. Okay, so in that case, sec squared x can be written as, well, tan squared x, well, that's going to be u squared, just using our substitution here, so that's u squared plus 1. So in that case, if we want sec to the power of 6 here, this becomes u squared plus 1 to the power of 3. So here now, we can start rewriting this integral again now. So we go back to our original pen colour here. Well, rewriting this integral then, using this part here of sec to the 6, x is equal to u squared plus 1 to the power of 3. So this now becomes u squared plus 1 to the power of 3 all over u to the power of 8 du. So here now what we want to do is expand this, well, this product of 3 brackets here. So you can use binomial expansion if you want, or you can just write this as a product of 3 brackets and then expand it. But what you should get here is u to the 6 plus 3u to the 4 plus 3u squared plus 1 all over u to the 8 there, okay, with respect to u. So now, if we simplify here, this u to the 8, this denominator of u to the 8 here, what we're going to get then is the integral, and hopefully we don't run out of room here, of u to the minus 2. So this is u to the 6 over u to the 8, so that would give us u to the minus 2. So essentially I'm just dealing with this denominator now. So that's going to give us u to the minus 2. 3u to the 4 over u to the 8, well, that's going to give me plus 3u to the minus 4. So that's 3u to the minus 4. I've got 3u squared over u to the 8, so that's going to give me 3u to the minus 6. So that's 3u to the minus 6. And finally, 1 here over u to the 8. Well, that's just u to the minus 8. So plus u to the minus 8. Okay? And that's all with respect to u. So, we're nearly there now. We're just running out of room ever so slightly. So, make note of this part here. What we're going to do now is just clear the screen just so we can finish this question. So now, if we finish where we were up to, in this case now, we just need to start integrating each term as we go along. So, we had the integral of u to the minus 2 plus 3u to the minus 4 plus 3u to the minus 6 plus u to the minus 8. And that was all with respect to u there, du. So here, we start integrating this. What I'm going to get here is minus u to the minus 1. So minus u to the minus 1 minus bracket. So we'll write this in a bracket just to make it clear here. This is 3 times a third of u to the minus 3 minus 3 times 1 over 5. So this is for the 3u to the minus 6 now. 1 over 5u to the minus 5. This u to the minus 8 would simply become minus 1 over 7 u to the minus 7. And here now, don't forget our constant of integration here. We have no limits, so we need plus c. So here now, we can simplify this to give us minus u to the minus 1 minus u to the minus 3 minus 3/5 of u to the minus 5 minus 1 over 7 u to the minus 7. Okay, and don't forget again our plus c here. And again, it's quite long, but we're still not finished just yet. Remember, we have the substitution here that u is equal to tan x. So here now, we just simply need to use our substitution. So this minus u to the minus 1, just to make it clear what's happening here, this minus u to the minus 1, that would be the same as writing minus 1 over u. Now, minus 1 over u would be the same as minus 1 over tan x, using our given substitution here. And remember, 1 over tan x gives us cot x. So this is minus cot x. So here now, we simply need to go back across here and use our original substitution here of u equals tan x. So in that case, what we're going to get here now is minus u to the minus 1. That simply gives us minus cot x. Minus u to the minus 3. That's minus cot cubed. So minus cot cubed x. Minus 3/5 here, so that's minus 3/5 of cot to the power of 5x. We've got minus 1 over 7 u to the minus 7, so that's minus 1 over 7 cot to the 7 x. And then finally we've got our plus c there. And then we have arrived at the solution. So like we said, quite a long question there, and you can just see how difficult these questions can be. But that gives us everything we need there for trigonometric integration by substitution. And that concludes this Maths Made Easy video on integration by substitution.